A rock is thrown horizontally from the top of a cliff that is 80 meters high with an initial speed of 15 meters per second. Assume air resistance is negligible. So the first thing I'm going to do is I'm going to draw a picture. This is my cliff, and I have a person that is going to throw the rock horizontally. And I know that even though they throw it horizontally, it's going to start to curve down and drop to the ground. Now I want to write out what information I have. I have that the height of this cliff is 80 meters. Since it's starting at the top, that's going to be my initial position, is 80 meters. And it has an initial speed of 15 meters per second. So we were given an initial speed of 15 meters per second. One thing that I need to consider is that I am given speed and I need velocity. Also, this object is thrown horizontally, but it's going to move in a vertical direction. So this means that I have an initial velocity in the x direction, right, because it's moving horizontally, that is 15 meters per second. My initial velocity in the y direction is going to be 0 because this ball is thrown horizontally. So there's no initial velocity in the y direction. I also know that I have acceleration in the y direction due to gravity, that's negative 9.81 meters per second squared. And because the only thing that's acting on this is gravity, I have an acceleration in the x direction that is equal to 0. This is all the information that I have in this problem. So now I want to figure out what it's asking me for. So we want to figure out how long it takes for the rock to hit the ground. We want to figure out how far horizontally from the base of the cliff does the rock land. So I want to figure out my displacement in the x direction, right? I want to figure out how far the object moves in the x direction. And I want to figure out the magnitude and direction of the velocity just before the rock hits the ground. So I want to figure out the final velocity of this rock. So this is going to be a 2D kinematics equation, meaning that I have to consider the x and y directions separately. That's why I have the x and y subscripts on all of these variables here. So I want to write down my kinematics equations. So now that I have my kinematics equations written out, we can start to solve this problem. So the first thing that it asks us for is to figure out time. How long does it take for the rock to hit the ground? The easiest way to go about determining how long it's going to take is going to be only considering this y direction. That's because I know that my initial position of the ball is going to be 80 meters, and I know that because it's going to hit the ground, my final position of this ball is going to be at 0. Since I'm going to be using the y direction to solve this, I'm going to rewrite all of my given information, but only for the y components. So I have that my initial position is 80 meters. I have that my final position is 0 meters. I know that my initial velocity in the y direction is 0. I know that my acceleration in the y direction is negative 9.81 meters per second squared because gravity is acting only in the y direction. And I'm looking to find time. So now I'm going to take this information that I have and try to figure out which kinematics equation I can use to solve this. So because I'm looking to solve time, I can't use equation 4 because equation 4 doesn't involve time. I don't have a final velocity, and I don't have time, so this would give me two unknowns for the first. I don't have final velocity, I don't have time, so this would give me two unknowns for the second equation. This means that I have to use the third equation to solve this. It's the only one that contains the variable that I'm looking to find, and also doesn't have any other unknowns. So I need to rewrite this. And since I'm in the y direction, I'm going to rewrite this using y's instead of x's. So y final is equal to y initial plus my initial velocity in the y direction times time. Notice that I don't have a subscript for time because time doesn't have x and y components. So now, because I have zeros, I'm going to go ahead and plug those zeros in and see if I can simplify this equation a little bit. If I were to go about this without plugging in the zeros, I'm going to end up needing to use the quadratic equation, and I don't want to do that. If you want to see that, I've done that in other videos, but I don't want to do that in this video. So I'm going to go ahead and plug my zeros in. So my final position is 0, initial position. My initial velocity in the y direction is 0, meaning that this whole term will go to 0, plus 1/2 acceleration in the y direction, time squared. So this is really going to simplify the equation, and I am going to rewrite this, moving the initial position to the right-hand side. Now I need to get time by itself. So we will have that time squared is equal to -2 y initial divided by acceleration. I need to take the square root, and whenever I take the square root, I need to have this plus or minus. And it's easy to determine with time whether it's going to be a positive or negative number because we can't have negative time. So my time is going to be equal to the square root of -2 times 80, because that was the initial position, divided by -9.81. And I get that the time is going to be 4.04 seconds. So this is how long it's going to take for the rock to hit the ground. The next thing I want to determine is how far horizontally from the base of the cliff does the rock land. So because I'm now wanting to know horizontal, I need the x direction. So I'm going to go ahead and rewrite what information I have in the x direction. And note that I'm solving for the displacement in the x direction. So I know that it's going to take 4.04 seconds for this object to be at the end of its motion. I know that my initial velocity in the x direction is 15 meters per second, right? Because they threw it horizontally, so all of its initial speed was in that x direction. And I know that my acceleration in the x direction is 0. That's because gravitational acceleration only works in the y direction, and this 0 is going to really help me out. So I can look through here. I need to remember that I don't know what my final velocity is. So I need to find an equation where I can solve for x, so automatically equation 2 isn't going to work, but I also need an equation that doesn't involve final velocity. So equation 1 involves final velocity because it has that average velocity. We also have the x final that we don't know, meaning that I would have 2 unknowns. I can't use that equation. And the same thing applies for equation 4. I would have 2 unknowns because I don't know my change in x, I don't know my final velocity, meaning that I need to use kinematic equation number 3. So x final is equal to x initial plus my initial velocity in the x direction times time plus 1/2 acceleration time squared. Because I'm solving for delta x, I'm going to go ahead and move that x initial to the other side. Remember that at delta x, your change in position is the final minus the initial. So this will give me delta x is equal to the initial velocity in the x direction times time plus 1/2 acceleration time squared. Because my acceleration in the x direction is 0, that last term is going to go away, meaning that my change in position in the x direction is going to be equal to just the velocity in the x direction times time. So I would have 15 meters per second times 4.04 seconds, and I get that my change in position is going to be 60.6 meters. So how far does this rock land from the base of the cliff? 60.6 meters. The last thing it wants us to find is the magnitude and direction of the velocity just before the rock hits the ground. So because this is a 2D kinematics equation, I want to think about the x directionality of the final velocity and the y directionality of the final velocity. So the x direction is really easy, and we can just do this conceptually, right? So if I look at the second kinematic equation, my final velocity is equal to my initial velocity plus acceleration times time. Well, if I have zero acceleration in the x direction, this means that my final velocity in the x direction has to be equal to my initial velocity in the x direction. Because if there's no acceleration in the x direction, we can have no change in this velocity here. So automatically I know that my final velocity in the x direction has to be 15 meters per second. Now I need to determine what my final velocity is in the y direction. So to do that, I'm going to try to determine which is the easiest equation for me to use to find that final velocity in the y direction, and I think it's going to be equation 2 again. So I have that my final velocity in the y direction is equal to my initial velocity in the y direction plus the acceleration in the y direction times time. So my final velocity in the y direction is going to be equal to, well, I had no velocity in the y direction initially, and then my acceleration due to gravity in the y direction is negative 9.81, and my time is 4.04 seconds. So this means that the final velocity in the y direction is going to be negative 39.6 meters per second. But this is not the end of my solution, right? I need to rewrite this as a vector. So there are a couple of ways that we can do this. The first way that I think is the easiest is that my velocity final is going to be 15 meters per second in the x direction minus, because I have this negative sign here, 39.6 meters per second in the y direction. We can also do this in polar coordinates, right? So we can determine that the magnitude of our final velocity is going to be the square root of the x component squared plus the y component squared, right? This is just Pythagorean theorem. And we get that the final velocity has a magnitude of 42.3 meters per second. And now I need to find directionality, right? So I can use that theta is equal to the inverse tangent of the y component over the x component. And we get that our angle is negative 69.3 degrees. Keep in mind that the negative 69.3 degrees tells me that our vector would be pointing this direction. And that makes sense, right? Because if I have a cliff and I throw a rock off, it is going to be moving in this direction. So this is telling me that I have a vector pointing that way. And I have the x component of the velocity is going in the positive x direction. The y component of the velocity is going in the negative y direction. So if I add these two together, I would get a vector pointing in this downward, forward direction.